Alright, so what we're going to do now is we're going to look at this example problem that we've looked before. What was it? I can't recall now exactly. Was it 1,000 newtons? This is 1,000 newtons that we pull here. X goes here from 0 to 1. The area was, okay, so the area was 0.002 minus, and this was 210 gigapascal if I recall. That's about it. Okay, but the bottom line is this is that problem that we solved already with the weighted residual approach with that form for U that we assumed, and then our form for W that was all in a normal X coordinate system. Okay, so the normal polynomial, quadratic polynomial assumption that we made there. What we're going to do now is we're going to solve exactly the same problem, but we're going to use the finite element method. Okay, so we're going to first off say this is our structure, this is our domain. First, before we can solve it, we're first going to have to discretize it and say we're going to put down some nodes. I'm going to put down one element, one quadratic element. Okay. Okay, so essentially we're going to put down one quadratic element as we showed, as we discussed yesterday, in terms of we have the 3 nodes here that we have, and if you look at the number of the terms, how they multiply, that was sort of a quadratic polynomial that we added up together. Okay, and then what we're going to do is we're going to call this Q1, Q2, Q3, and these will be my unknowns that I'm going to be solving for. Okay, so this is what we're going to do. So once we do that, we know we can describe the displacement as N1. So let's write it like this. U is a function of psi now. This is still in the X domain that I'm putting, but remember, we're going to map this 0, 1 domain into this new world, which we're going to call psi from -1 to 1. Okay. And this will be called Q1, Q2, and Q3. What we're going to do is you can take N1 psi okay. So that's our first assumption we're going to make. So make sure it's on the screen. And then what we're going to do is, not assumption, this is what's going to follow once we put down the nodes. So what is important is by dictating how many nodes we put down, we dictate what kind of element we're going to have. If I'd only put down 2 nodes, I would have gotten what's called a linear element. Okay, and you're welcome to go and see in the textbook how they derived. But before you look at how they derive, please see if you can try them on your own. It's really something that it's like an easy to go through. Okay, so and then W, I'm going to try and make it this sharp W's. Will follow that we essentially then have N1 W1 plus N2 W2 plus N3. Let's put that sign there. Okay, and this is just my displacement field, and what will follow is I have to assume the same form as the displacement field for my weighting function to apply the weighted residual method. Okay, so this is what we're going to tackle. I'm going to go over to the PDF and let's tackle this problem step by step by going through what's required. Okay.